Hello, Assalamualaikum. Good day to my lecturers and my fellow viewers. My name is Sahrin Haikal, and today I will be presenting my individual project for the Big Data course. My project focuses on big data analysis using Hadoop MapReduce framework. In this presentation, I will demonstrate how we can take raw medical records and transform them into meaningful insights using distributed computing. The primary objective of this project is to implement a scalable solution for counting patient diagnoses. Specifically, I aim to implement a MapReduce program for processing large-scale hospital records to analyze the frequency of specific diagnoses, example heart attacks and diabetics. Number three is to prove data-driven insight for hospital resources allocation. Why are we using Hadoop? In traditional system, processing thousands of hospital records can be slow and resource heavy. According to the principle of big data, MapReduce offers a parallel processing model. This means the data is broken into chunks, processed simultaneously across different nodes, and then reassembled. For healthcare, this is efficient. This efficiency is vital for real-time monitoring of disease trends and ensuring the batch layer of the big data architecture is robust and reliable. For this analysis, I chose a hospital patient record data set from Kaggle. The data is in CSV format. It contains columns such as patient ID, gender, and etc. Most importantly for this project, the diagnosis column. During my initial data survey, I found the records were unstructured in terms of frequency, making it impossible to see trends by just looking at the file. My task was to extract the fourth column from every row to perform a tally. This flowchart illustrates the MapReduce lifecycle. It starts with input splitting, where Hadoop divides the CSV into manageable blocks. Next is map phase, which filters the data. Following is the shuffle and sort phase. This is internal Hadoop process that groups all identical diagnosis key together. Finally, the reduce phase aggregates this group into single count, leading to our final output stored in HDFS. Looking at the code for the mapper, I extended the mapper class from the Hadoop library. The logic here is simple but powerful. For every line of text, I use a string tokenizer or the dot split method to find the diagnosis. I then emit a key value pair where the key is the name of the disease and the value is a constant 1. This signal to Hadoop that we have found our instance of this specific condition. The reducer receives a key and an iterable list of ones. In this section of code, I initialize a sum variable to 0. I then use a for each loop to iterate through every one collected during the shuffle phase and added them to my total. Finally, the context.write method outputs the diagnosis name alongside its final calculated sum. This is where the actual counting happens. The driver is the brain of the application. Here, I configure the job by setting the jar files, the mapper, and the reducer. I also define the output key as a text type and the value as an int writable. Most importantly, I set the input and output paths based on the arguments I will provide in the terminal. This ensures the program knows exactly where to find the hospital data and where to save the final report. To run this in my VirtualBox environment, I first move my local file into HDFS. I use the command hdfs dfs-put hospital*.csv /input underscore dir. I use a wildcard * character here to avoid errors caused by spaces in file names, which is common technical hurdle in Linux environment. Once the data was in HDFS, I executed the jar file using the Hadoop jar command. This triggered the map and reduce percentage you see on the screen, providing the distributed process was active. The results were very insightful. After running the cat command on the output file, we can see that the condition like heart attack and fractured leg appeared 67 times each. This suggests a high demand for emergency and orthopedic services. By having this exact number, a hospital can optimize its inventory for medicine and ensure that enough specialist doctors are on the shift to handle the most frequent cases. In conclusion, this project successfully demonstrates the power of Hadoop MapReduce in transforming large-scale hospital record into actionable insights. Through this individual task, I have gained hands-on experience in big data manipulation, from environment setup to Java programming and data analysis. This concludes my presentation. Thank you for your time.